Yeah, we will start Taylor expansion. They call it expansion. They call it series, the same name, right? So expansions or series or polynomial, because it is already polynomial, right? So you have two type of Taylor series. One variable function, right? And multivariable function. Okay. The one variable function, you find the Taylor series or Taylor expansion or the Taylor polynomial for one variable function. This is the independent variable here, only one. So you call it one variable function. Okay. So you get the Taylor series at a specific value for x, right? Okay. So if say x equal to c, right? So you need the derivative. Look at this one. You need the derivative, right? So you have to know how to differentiate your one variable function. Fine. In the beginning, you find the value at x equal to c, right? And then you have the first derivative at x equal to c. Multiply by this factor and do the same. Remember, you have factorial here, right? So this is the general term. This is what? The general, yeah. Okay. C is a value of x. You find the polynomial or Taylor series at a specific value for x, right? If you have x equal to 0, they call it Maclaurin series, right? If x equal to 0, we call it Maclaurin series, Maclaurin or Maclaurin expansion, right? So this is special case for C equal to 0. They call it Maclaurin expansion or Maclaurin series. But x equal to c is the general one for Taylor, right? Okay, it is infinite series. This is the problem with the Taylor series. It is an infinite polynomial or infinite series. So you have to stop at a specific point, right? So it depends. If you stop in n equal to 5, so the remaining will be function of x to the power 6, right? Okay, this is how to, when you stop, it depends on the remaining here. Okay, this is they needed in engineering because they would like to have the expansion up to specific error, right? So they need the error shouldn't be exceed this value, right? So they know when they are going to stop, right? In your level, they ask you to find Taylor series for first degree, second degree, third degree, etc., right? Let's go and apply it for the function f of x. What you need to find the Taylor expansion, you need the value of x equal to c, the value of the function, right? So it is equal to what? E to the what? C. C. Now you need the first derivative, which is also e to the x, right? So you need the value of the derivative at x equal to c, right? To plug in all of these one in the formula, right? You still have e to the c. Because you are lucky, this function has a derivative always e to the x, right? So all the derivative are the same, e to the c, right? So if you carry on, f to the derivative n of x equal to c is ac. But if you have different function like cosine, sine, it is, you know, alternating from positive and negative. And this, if you have x, ln x or logarithm x, that's okay. You shouldn't have the same differentiation. This is exception for exponential function, right? E to the x. Also, if you have e to the 5x, it will be different, right? Because the derivative of e to the x is e to the x. The derivative of any constant next to it will be a e to the ax, right? Okay. Now, let's go and plug in the formula. Here is the formula, right? Your function is e to the x, right? Equal to your function at x equal to the first term, e to the c, right? Plus f dash at c is also e to the c. This factor is, leave it as it is, right? X minus c, right? Plus, again, e to the c over factorial 2, right? X to the minus c square, right? Plus, etc. The general term, I know the function is still the same thing, right? X minus c to the power what? N plus the remaining, right? Remaining of x and c. Okay, that's good. Now, if I give you c equal specific value, right? Fc say equal to 0, right? So e to the x will equal to what? This will be 1, right? E to the 0 is 1, right? E to the 0 is 1. E to the 0 is 1. So your Taylor series for this one will be what? 1 plus x minus 0, x plus x minus 0 square plus this is the Maclaurin series, right? Catch the point? So here is the formula. You need the value of the function at the specific point you want to find the Taylor series at, and then you need the first derivative, and you need also the second derivative at the same point. You need the nth derivative at the same point, right? And remember, Taylor series is infinite series. So when you stop, you should have a remaining here, right? Now, are you okay with the one variable function Taylor series? Good. Let's go for the two variable. I think you know what does it mean, Hessian matrix, right? We have Hessian matrix for two variable. Do you remember it? Yeah, I do. Partial square f by partial x square, and here partial square f by partial y square, right? And here, what do you have here? Partial square f, partial x, partial y. And here, partial square f, partial y, partial x. We know partial square f, partial x, partial y is the same as partial square f, partial y, partial x. It doesn't matter. You start differentiating with respect to x, or you start differentiating with respect to y, right? So this is, we call it the Hessian matrix in two, for the function of two variable, right? This is for n variable because you have x1, x2, x3 up to xn. Why we remember Hessian matrix again? Because we are going to insert this one in the Taylor series for multivariable function, right? Good. Look at this one. This is the Taylor series, Taylor expansion of degree what? For function of two variables, right? So this is your first term. This is the second term of degree what here? 1, first degree. Here, because you have a square, this is the second degree, right? And also here 1 and 1, you have second degree, right? So he will ask you to find the Taylor series for the first degree and second degree. You know, if it is first degree, you will stop at this one, right? So here, first degree, right? Only. Okay. But if you have this one and also this one, this is, you call it what? Second degree, right? Catch it? Okay. Now, what do you want? You want also the value of the function at the point. But here, because you are in 3 dimension because you have 2 variable function, right? Here is the function here of x, y, and we call it z, right? So you have any point here represent x and y, right? So z is a function of x and y. So in one variable function, you have x equal constant, right? X equal a constant here because you have one variable, right? In the two variable, any point is x and y, right? So you have C and D, right? C for x and D for what? For y. So you need the function at this two coordinates for the point. And also you need the partial derivative because we don't have one derivative. We have two derivative, partial derivative, first partial derivative because we have two variable, right? And we have the second degree one with the second order partial derivative, right? So as in one dimension, you have to find the value of the function at the point. Here you do the same, and the partial derivative at the same point, and the second derivative at the same point. These factors are fixed, right? This one are fixed, right? So you only, in this example, he give you the point C and D here is what? 1 and 2, right? He's asking you for the second degree or the first degree, it depends. He's asking for the second degree, right? He give me the value of the function 29. So I plug in this one as 29, right? Okay. So now this is 29. The first derivative at x is 19. So this one will be what? 19. What is C? What is C, Alan? Excellent. So x minus 1, good. The first derivative with respect to y, how much is it? 24. So I plug in the 24 here instead of this one. Y minus d. What is d? Excellent, right? I will carry on. 1 over factorial 2 is fixed, right? The second derivative, this one, 22, multiplied by x minus c. What is c? Square. This 2 is fixed. This one, how much is it? 10. 8. Okay. C and D, I got this one, right? X minus 1, y minus 2. I'm just plugging the values, right? You are lucky because in this case, he gave you the value. He didn't ask you to differentiate and substitute, right? Next time, I will let you practice the partial derivative, right? What is the value of this one? 10 multiplied by y minus d. What's d? Square, right? Easy? Yeah. Go for this one. Go for this one. Yes. I will leave this one for you. Yeah, the same one. By mistake, I copied twice. Size for today, right?